So today, adding to our amplitude and our period changes, we're going to start moving into vertical translations and phase shifts. Now that sounds really strange, okay? Vertical translations, moving the graph up and down. Phase shifts, which can also be called horizontal shifts, moving the graph left and right. So now instead of smashing it and opening it, it's just going to go other ways. All right, thank you. So the first thing we're going to do is simplify. See, mathematicians sometimes, they like to make things more complex than they need to be, or do things that to me aren't sensible. And here's what I mean. For instance, with these guys. We just got done talking about how you can have a cosine b of x, where a changed my amplitude, b changed my period. Now, why you would decide the next logical letter to put in here is k is beyond me, so we're not going to do it that way. Now, I'm going to do something strange, though. Since we're going to work on vertical, up and down shifts first, okay, instead of using k, we're going to use d. Now, you're like, Harty, last time I checked in the alphabet, it goes A, B, C, D, not A, B, D. C will be coming, okay? It just fits into a different spot. So, for our purposes, we're going to consider D to be our vertical shift of the whole graph, just because it's going to make more sense here in a bit. And what that means is there's a change in what's called the center line. And that's something new to us today. The center line we represent with y equals, like we would a horizontal line. And when nothing else is going on, this starts at y equals 0. So in other words, it starts on the x-axis, and it'll move up or down depending on what that d value is. So similar to things we've done before with shifts, if my d value is positive, so like if I have plus 2 or something, my whole graph moves up that many units. If it's negative, it goes down that many. So if it was like minus 3, my whole graph would shift down 3. And then the last two letters here are the ones we've been working on for a couple of days. A is my amplitude change. Normally it's 1, but it can start to make my graph get taller or skinnier. Okay? We haven't gotten into negative amplitudes much yet, so we'll chat about that. And then B is my period change, where I take the old period, which for our purposes would be 2 pi, since we're not dealing with tangent stuff, and dividing it by b. And then we just remind ourselves here as well that dividing by b is the same thing as multiplying by its reciprocal, because more times than not, that's what we've been doing. We've been multiplying by 1 over. Okay, so we're going to kind of jump in with 2 feet here. So our first example, and what I'm going to typically do, if I see this value in front like that, I'm just going to move it to the other end because I don't like it there. It just kind of gets confusing for everybody all the time. So if we ever see it on a worksheet or anything, we'll move it as well. And so here, what ends up happening is that I want to list these values. Now, we're used to some of this. Okay, the amplitude we're used to. That's 3. The period we're used to. That's 2 pi divided by b. Now, this one I may have to think about a little bit, maybe even do a little bit of side work. Because remember, when you divide by 2/3, that's the same thing exactly as multiplying by 3 over 2. And if I work that out, 6 pi over 2 would tell me my period is going to be 3 pi. So again, a little bit of side work doesn't hurt anybody. But then our new piece of our graph is this d value, which we call our center line. And so since it's positive 3, my center line will now move to 3. We'll get to that at the very end, though. So, what does that mean for when we go to graph these? Is it going to change a whole bunch of stuff? Not really. All that's really going to happen here is we're going to make a little bit of an adjustment. So, here's where I am going to introduce the card that you just got. And basically what we're going to do is we're going to copy on each side of the card what I've got over on the board there. And I'll get it up here too, so if people that aren't in class can actually see what I'm talking about here. Before, we talked about how the amplitude changed the value here, and my B value changed my degree measures. Well, what we're going to get into today with our vertical and horizontal shifts is they also will change one of each of those. So for this first part, our D, our vertical shift, is going to change my zeros and ones. And so what I would suggest doing is on one side of your card, doing what I've done here, I'm going to get my base angles and my base values down with some space, because that's why when I said we wanted a pencil, we're going to do some of the math right on this card lightly, and then we can erase and change things up instead of having to redraw it every time. And then on the back, when we get to a cosine graph, we're going to do the exact same thing with cosine. And just kind of get ourselves over the next couple of days into this rhythm of what goes with what, and then when it does come time for the quiz, you're going to have done it enough and kind of repeated the process enough that it's hopefully going to feel a lot easier, if not, a little bit better at least. So, you'll notice it doesn't change a whole lot on what we're going to be doing here. Like, for instance, here I notice a couple of things. And again, I'm going to bust out my pencil so I can do a little bit of erasing as I'm doing this. So I notice this time I do have an A value that's going to change things. Okay? My center line is a D value. So two things are going to be happening to these. But then my B value, my period change, is all that's going to happen here. So I know a couple of things with my period. I continue to know this is going to stay at 0. And I also know with my period, whatever I calculated it to be, that should be the value that I get at the end. Now the stuff that's in between, I need to multiply each of those by 3 over 2. Okay, so in this case, and this is why we're just kind of going light with pencil, pi times 3 would be 3 pi over 4. 3 times pi would be 3 pi over 2. 3 times 3 would be 9 pi over 4. And if I wrote this last one in, 2 times 3 is 6 pi over 2, which is 3 pi. Those 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, 3 pi are going to be my angle measures that I'm using. They're going to be the lines that I draw in my graph to be able to complete this graph within the period that I was asked to do. So once I have those, let's kind of do that for a second here. Then I change my focus to the actual values that I'm going to get out. Now here's the first time we've had to deal with this. I got two things going on. I have an amplitude value, but I also have a shift of up 3. because that's what my D is going to be. So what do? What order do I do them in? Notice the little numbers that I put above the letters here. That's the order you're going to do them in. So it's kind of fun because B comes before C, and A comes before D, and it's the same order I'm going to do them in. So my amplitude means my first job here is I'm going to multiply everything by 3, and then with a plus 3 for my D value, I'm going to add 3 to whatever that answer is. It's up to you if you want to do 2 separate things here, if you want to do all the times 3 and then add, or if you want to do them together. I tend to do them together. So here's how it'll work. 0 times 3 is still 0, plus 3 would be 3. 1 times 3 is 3, plus 3 is 6. And then anytime I get 0, I'm still going to end up at 3. That's just how this works. Negative 1 times 3 is negative 3, plus 3 is 0. And then this guy ends up back at 3 again. And those are the values that I'm going to be plotting. So, here's what this is kind of going to look like for us. Let me scooch this over a bit here so we can start drawing this in. So at 0, I'm like 3 and 6 and 3 and 0. I can sort of plan out my lines this way. I mean, you could still count by 1s or 2s. That's fine. It really doesn't matter. But if you see a pattern, like multiples of 3, it makes it a little easier. I can get my angle measures labeled. And once I've got those, now I can just follow along with my values. So instead of starting at 0 for my sign, I start at 3 because of the shift up 3. 3, 6, 3, 0, 3. Get my curves in. And then the last thing that I'm going to put into this is going to be this center line. And this center line basically is just a dotted line that goes right through the middle of my graph. So there's a couple of ways you can remember that. First, basically that value you keep seeing show up over and over is going to be the value it's going through. But if I was making a horizontal line at y equals 3, basically what I'm doing is I'm kind of getting a reflection line in there, a line of symmetry. And that's all I have to do. So the biggest thing when you're doing these is going to be just reminding yourself what this is going to look like. And when we do this for the next one, I'm literally going to do it on the note sheet because I want you to actually be able to see how this chart works on there too, just in case. Oh, of course, it's got to be cosine when I'm supposed to be doing the other side. Oh, well. So you can kind of see how this works. Maybe we'll do cosine on the card, and then I'll go back to the note sheet. Issues so far. So again, we're just kind of adding that one little shift in. I have had some people in the past just draw the graph in instead with dotted lines and then shift all the points. It works. I have a video on my website that does it that way, but I really think this is going to be the best route for most of you. Like, okay, we're going to give this a chance before we say too much here. Okay. So number 2, now we have a cosine we're going to deal with. And again, I'm going to move this plus and minus stuff to the other end here. My D value, my up or down shift is 1. So everything's going to get shifted up 1. I do have an amplitude value of 2. And here's a new one. My B value is pi. Weird. Okay. So when it comes to start kind of thinking about these, my center line, again, goes with D. So that's going to be at y equals 1, because everything shifts up 1. I'm not quite sure why I put an A and amplitude, but okay, I'll just work along with it here. And then my period. My period is 2 pi divided by b. Well, when you divide 2 pi by pi, the pi's disappear. You're like, but wait a minute, we're supposed to be in radians. Is it not in radians anymore? There's no pi. It's still in radians. You can have radians in whole number values. It's just going to look a little different. So you're like, okay, we're going to get this here. So here is the other side of my card. It's just what we had on the right. And the only difference at this point, really, since the angles are all the same, are my cosine values. Because I start at 1 instead of starting at 0. So I start to take a peek at what's available. Okay, what's changing this time? Well, we're in the same situation again. I know that my period is 2. So I know when I'm looking at this, I'm going to start at 0. I'm going to end at 2. And when you divide by pi, that's the same thing in this case as multiplying by 1 over pi. So basically, all you're going to do with your fractions all the way down is slap a pi in the denominator. So every single one of these, the pi is going to cancel out because you've got 1 in the numerator from your initial angle and 1 in the denominator from when we just did our period work. So I end up with a half, 1, 3 over 2, and 2. So I can kind of see how that works. So that part's not too bad. But then I get to the other part again. And just like we had with our sine graph up above, I have an A value of 2, but I also have a D value, okay, of 1. They've always got to go in the order. The multiply number comes first, so we're going to times by 2. And then the add or subtract number will come second. We're going to add by 1. So I look this over and I go, all right, so I've got 1. So 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. Negative 1 times 2 is negative 2, plus 1 is negative 1. And we said before, if I get the same numbers, they end up being the same values. So there's my lines of my angles. There's the values of all of those at cosine. So shift this over a bit. It's going to seem strange at first, not seeing pi anywhere, but we'll make it. And on this one, since we've got different values, we don't really have multiples of anything. I'll just go ahead and count by 1s on each of these. And now it's just basically take the chart and work it. So at 0, I'm up at 3. At 1/2, I'm at 1. At 1, I'm at negative 1. At 3/2, I'm back up to 1. And at 2, I head back up to 3. Remember, we're at doing curves with these. And my center line is at y equals 1. So, oops, I don't need an arrow. And I get that value in there. Issues, issues, issues so far. I really would suggest kind of playing this card game unless you're super confident you can just knock all this stuff out in your head. Alright, let's see. How do I want to play this? Let's do this. Let's pop one more piece in. So I'm going to take my card here. We're going to head to the back of this sheet. I'm going to go past number 3 for right now. Ooh, no I'm not. I just saw something that's new with it. We are not passing up number 3. All right. Here's why we are not passing up number 3. We've got some slight changes to some things, and I want to make sure that we don't get ourselves in trouble here. Okay, so I noticed back here. What's my d value going to be on number 3? -2. Okay, which means my center line will be at y equals -2. Okay, nothing real fancy with my amplitude. Okay, that's 2. Oh, Harty, gracious. Pi and a fraction? Seriously? Well, you know, sometimes we gotta try some new things out here. So I'm going to have 2 pi, and I'm going to divide it by pi over 2. But just remember what you're doing with this. And side work doesn't hurt anybody. Remember, if you're dividing by pi over 2, you're multiplying by its reciprocal. And when you multiply by the reciprocal, the pi's go away. And we're back similar to what we had in the last one with a period that doesn't have any pi in it, which actually is kind of nice. So what I'm going to do on this one, I said I was going to do it on 2, but we had a cosine. I'll do it on 3 here. I'm actually going to draw my chart right in on this one, just so if some of you misplace a card, something, you'll actually have some access here. So, got my theta, got my sine theta, just like we have on the other things. And I start to look to see, okay, what's going to change here? Well, here's what I know. And if you've gotten to a point that you know your base angles, what I'm writing here off the top of your head, you may not have to write everything out. I don't know. Because here what I know is, I know this last theta value is going to be 4, because I just figured out that's how big my period is. I know this first one is going to be at 0. And so now for the rest of these, I'm going to multiply by 2 over pi all the way through, which just like the last one, over pi, is basically just going to wipe the pi's out. 2 divided by 2, remember, numerator, denominator is 1. Pi's get canceled, 2. Pi's get canceled. 3 times 2 is 6. Divided by 2 is 3. And pi's canceled. 2 times 2 is 4. Sweet, I did it right. It's nice to have that little check in there at the end. But then when we get to sine, just like it's been on the first couple, we're going to have that issue where we need to do 2 things. Because I have an A and a D value. So first, I'm going to multiply by 2. And then second, I'm going to subtract 2 because my D value is negative this time. So I'm like, all right, 0, 1, 0, negative 1, 0. So 0 times 2 is 0, minus 2 is negative 2. 1 times 2 is 2, minus 2 is 0. Okay, the 0 value will be the same. Negative 1 times 2 is negative 2, minus 2 is negative 4. And I've got my values. So there's my angle. There's my values. And I see everything in my values is multiples of 2, so I'll just go ahead and label my axes that way. So once we get those in there, let's see here. So we've got 0, -2, 1, 0, 2, -2, 3, -4, and 4, -2. And a center line at y equals -2. So how are we doing on our vertical shiftings? I got one more problem I want to do, because that'll give us plenty of time tomorrow to kind of play with this a bit. Okay, so one last thing to introduce here. Again, we got to get rid of this K stuff. K. So again, D is a vertical, an up-down shift. C, you're like, ooh, C. Okay, that's why Harty used D before, because C was coming. C is a left or a right shift. Instead of calling it a horizontal shift, which is what it actually is, mathematically often we call it a phase shift. But here's the cool thing. It's just like every other left and right shift we've been doing all year. Parabolas, square root functions, absolute value functions. It doesn't matter. We're doing the opposite. If it's positive, it goes left. If it's negative, it goes right. So that really hasn't changed much at all. So here's what we've got to think about. When we're doing these are the ones that are going to go hand in hand with my period change. So for instance, here, in letter A, my B value is 1/2. So my period is 2 pi divided by 1/2, or 2 pi times 2, which is 4 pi. However, we have a phase shift this time. That negative pi, or that minus pi, means I'm going to be shifting right pi. Now, that may not make sense right away on what that actually means. So let's kind of put this into context. Originally, my graph normally starts at 0, and that tells me the last value, sort of like when we're doing it on here. So, to start, it was going from 0 to 4 pi. That was my original graph before my phase shift. Once I have my phase shift, now each of those are going to have pi added to them to go to the right. So now my new period would go from pi to 5 pi. I add pi to each of those. So that's like what my first column would become. I'd add pi to each of my answers. Sort of like we did the 2 steps with multiplying these, we're going to do that same thing here. Or if you have one like, let's say, letter C, so this time I notice that my B value is pi. So to do my period, I do 2 pi divided by pi, which is 2. You're like, okay. So if there was no phase shift here, it would have been from 0 to 2. But there is a phase shift. this minus 5, which means we're going to move right 5 from wherever we are. So now, I add 5 because I'm going right 5 to that, and I add 5 so I'm going right to that. So now instead my period would be between 5 and 7 instead of 0 to 2 because I shift the entire graph that way. Weird, but true. And it would work the same way if I was moving left. I just subtract those values. So I actually want to do one of these. We'll be doing more of these tomorrow. Oh, trust me, we will. Just to kind of see how this works. So we're going to do this one at the bottom, then we're going to wrap it for today. And we'll clean up some of this tomorrow and kind of chat about some of it again. So graph at least one period of the following. Okay, let's see all of our fun stuff that we've got here. We don't have a value on the end because that negative 2 is my A, so I'm just going to put a plus 0 in here at the end. So my D value, I don't have one, or at 0, so that's nice. At least I don't have to worry about that. My A value, my amplitude is negative 2. My B value is 1. There's no number right in front of my X, so I don't have to think about that. So my period will just be 2 pi, or 2 pi divided by 1. And then my phase shift, right or left pi over 2? Right. Okay, so right pi over 2, or in our world, add pi over 2. You're like, oh boy. Okay. So Harty, how's this going to work now? Because here's what's changed. When we were talking before about playing around with our card, and I'm going to do this one right on here again, just so you can kind of see what's going on. So I've got my theta. And if you need to use more room here to the left, that's fine, because we're only going to use a piece of this. So once I get those listed, here's what I've got to pay attention to. We talked before about how when we're doing these, theta is affected by B and C. By a period change, which there isn't one, because it's 1. But also if there's a phase shift. Well, there is. So this time my phase shift means I'm going to be going right. I'm going to be adding pi over 2 to all of these. So every one of these, so 0 plus pi over 2 is pi over 2. Common denominator, that's awesome. Pi over 2 and pi over 2 would be 2 pi over 2, which is pi. And if you don't like playing the common denominator game, you don't have to. You're like, what do you mean? Well, let's think about the pattern. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is 2 pi, and 5 pi over 2. To which some of you, your brains are all of a sudden have this red light flashing off, and you're like, Harty, wait, the period's 2 pi. That's not 2 pi. Remember, we shifted everything right too. My old period was 0 to 2 pi, and that would have been true. But now we added pi over 2 to each of those. So 2 plus 1/2 is 2.5, or 5 pi over 2. We're A-okay. So when we're graphing these here momentarily, it just means our graph took a little bit of a move on us. So we've got our angle measures ready. The other part, a nice deep breath, is going to be easy compared to what we just did. Because now when I do cosine of theta, remember, that's my A and D values. So, I got to multiply by -2, but there is no vertical shift. My D is none or 0, so I don't have to do anything for that part. So it's just multiply my cosine values by -2, and I'm good. Negative times negative is positive. And I've got my points to plot. Uh-oh. Thank you. I'd have figured that out as I started to plot points. I'd have been like, wait a minute, why? Ooh, that doesn't look right. So I can go ahead so at pi over 2, we're at -2. At pi, we're at 0. 3 pi over 2, we're up to 2. At 2 pi, we're at 0. And at 5 pi over 2, we are back down to the negative. Again, curve as best as you can. If I needed to continue the pattern, I could, because I'd know this would be heading back to 0 if I wanted to keep going there. This would be going to 0 next if I was going to there, and so on. Okay. So here's kind of what you're capable of at this point, at least if you're brave enough to jump in. We will be finishing off the rest of the examples tomorrow to look at. For now, what I would say is you had this worksheet from Monday. Now, if you're looking at this in a future year, it may be a different day. But the one more trig graphing practice where we did like the odds and a couple with the cosecant and secant, I would say work on some of the evens in there now, because that's going to be the rest of the assignment in here. It's going to get you a little practice with single parts, multiple parts, shifts, all that fun stuff. Okay, get you a little bit of practice, and then we'll add a little bit to it tomorrow once we finish off the examples. But if need be, go back, check this out later. We'll go over it some more tomorrow, and we'll do more then.